All right, let's now have a look at the practice problems here. So we're going to start with number 2. So we have a semicircle radius 8 that's rolled up to form a cone. We want to compute the volume of the cone. So again, you might recall from the previous video here, we're going to take this and turn this into a cone. So this is 8 here, and we're going to turn this into a cone. Now you might remember from before when we were to roll this up, we see that this 8 here, the radius of 8, is actually going to be the slant height of the cone here, because this is going to be the apex like this. So this is going to be 8 over here. Now, unfortunately, we don't know what the height or the radius of this bottom circle is, but we can determine that here from a couple of ways. So one way is the fact that this here, remember that the bottom arc here gets rolled up to form the circumference of the circle here. So we can actually determine the length of this arc from A to B. So AB here has a length equal to 1/2, since it's a semicircle, so it's going to be 1/2 times 2 pi times 8, since the radius is 8. So we know that's going to AB is going to be 8 pi, and that's going to turn into this on the bottom here. So it's going to turn into this sort of thing on the bottom here. So that's the circumference of the circle, and we know that's 2 pi r. So therefore we now know that r equals 4. Alternately, you can also use the fact that this becomes the lateral area of the cone, so you can actually find the area of this object here and then use that to determine the radius as well. Up to you. You'll still end up with 4 at the end. So now we have this. So now we can actually figure out what the height is here. Now we have a right triangle like so. So we know that 8 squared plus 4 squared equals 8 squared. So 8 squared equals 64 minus 16. So 8 squared is 48 here. You get h is, I believe, 4 radical 3 here. So now that we have all that, we can put it all together. The volume is just 1/3 the area of the base, which is pi r squared, times the height. That's 1/3 times pi times 4 squared times 8. Sorry, not 8. 8 is not the height. 8 is the slant height. So the height is 4 radical 3. Now, unfortunately here, as you can see, these 4, the radical 3 doesn't cancel with the 3, and we have all this. So in fact, 4 squared times 4, that's 64. So in fact, it's going to be 64 pi radical 3 all over 3 here. And that, unfortunately, is the nicest way to write this. So this is going to be the volume of our cone here. Okay, problem 4. So this comes to us from an old ARML. This is from a contest from the 80s or something. So you have a cone, as you can see, a cone with diameter k. Oops, I screwed that up. This is diameter k, and this is radius k here. It rests in the base of a right circular cylinder radius k. The cylinder is filled to water with a height of 12. If the cone is removed, compute the height to which the water will fall. This isn't too hard here, because now we can take a look at what's going on with this sort of thing here and see what's happening with that. So the idea behind this here is that, well, first off, the first thing to note is that the cone plus the cylinder, right, plus the water, right? In this case, or not the cylinder, actually. It's just the cone plus the water. The cone plus the water is going to be a cylinder with radius k and height 12. So the volume of that is going to be pi r squared times the height, which is pi times the radius squared. So the radius of the cylinder is k, and the height is 12. So you get 12k squared pi. So this is the volume of the cone plus the water. Now, if we remove the cone is nice because we know that in this situation, so we can find the volume of the cone. The cone here is going to be, well, let's see, that's 1/3 the area of the base, which is pi. The radius of the base here, the cone has a diameter k, so it's going to be k over 2 is the radius, and the height is still 12. So let's see, this is going to be, all right, so you have 1/3 pi times k squared over 4 times 12. We note that the 3 and 4 in the denominator cancel with the 12 neatly over here, so these drop out, and we're left with k squared pi. Now with these two things here, this means that the water is going to be 12k squared pi minus k squared pi, and this becomes 11k squared pi, right? And the nice part about the water is that the water, when you remove this, the water is still going to be it's going to be a cylinder here, so we can set that equal to the new height. So we have 11k squared pi equals pi times the radius squared times the new height. I'll call it hn. So you have 11k squared pi is pi times the radius squared, well, the radius is k. And you can see everything neatly cancels, leaving us that the new height is 11. Okay? So let's move on to number 5. So this number 5 comes to us from an EME. So this is actually a fairly difficult problem here. So you have a right circular cone with a base R and a height h, and it lies on a flat table. So basically what's going on here is that you're rolling a cone around here. So it looks something like this at this point here. So imagine, this is a really bad looking picture, but imagine something like this here. I realize this looks kind of like an eye here, but you know, Illuminati and all that. But then, you know, it's going to roll around like this here, okay? So we're going to roll this cone around until it makes a full circle here. So the first thing to note is that for this cone here, right, the radius of this big circle is going to be the slant height, right? Because that's going to be our thing here. This point of contact between the cone and the table here, that's going to have a radius of L, okay? So I'm going to sketch our cone to the side here because that's going to be important to us later on, okay? So this is our cone here, L, H, and R. And we're asked to calculate what H over R is, and that's going to be useful later on. Now, the only number that we have is that the cone makes the full circle after making 17 complete rotations. 17 is a very strange number, but I wonder if it's useful. So this means here that this cone is going to make this point over here, let's call this point here K. This point K is going to trace around this entire circle here. Now, when it traces the entire circle, that means the entire path it's going to trace is going to be the circumference of the circle, which is going to be 2 pi times K, right? 2 pi times L, my apologies. So it's going to be 2 pi L. Now, we're also told that in addition to making this, it makes 17 complete revolutions of the base here, which means that this point K is going to run around, make 17 laps over here. So it's going to be 17 laps of this. So as a result, that's actually going to be 17 copies of the circumference of the base, which is 2 pi L. 2 pi R here. So now we know that 2 pi L equals 17 times 2 pi R, which is really helpful here, because that tells us here we can drop these out, and we're left with L is equal to 17R. That's really useful. Now, we need to get H and theta mix here, and we have this sort of thing going on. We have H, R, and L here. So again, just like we said before, we know that there's a relationship between these here. We can use the Pythagorean theorem on this right triangle here. So we know that H squared plus R squared equals L squared. So therefore, as a result, we can now plug in what we have here. So we get H squared plus R squared. We know L is 17R. So I'm going to write this as 17R squared, right? So that means H squared plus R squared equals 289R squared. Is that 17 squared? So you get H squared is 288R squared, and therefore H is going to be, well, let's see. It's going to be, since there's an R squared, it's going to become R, and then 288. 288 is nice because 288 is double 144. That's double 12 squared. So I can yank out, so this is going to be the square root of 144 times 2. So that's going to be 12R radical 2 here. And now, all they ask is what H over R is. H over R, well, let's see. H is just 12R radical 2. That's all divided by R. The R's drop out. And we're left with 12 radical 2.